Hi, welcome to Fun Pi videos. This is DC here. In this video series, I'm going to show you how to use Mifare Classic EV1 tags using PN532 reader writer. Throughout this video series, you're going to learn the following things. So you're going to see how to activate the card. You're going to see how to authenticate using the key A and key B. You're going to see how to read and write the data blocks, how to do the value block operations, how to change the access rights, and the PN532 specific commands and responses. In order to follow this video tutorial, you need a PN532 board connected in UART mode. So you can do that using a USB to TTL cable. And I have made so many videos already on using PN532 with the various other tags. And my recent videos were using the Mifare Classic EV1 tags, but using the reader writer from called ACR122U. So I would advise you to see those videos, and everything is covered in detail in those videos as well. So these videos are pretty technical, so probably this is going to be useful for the software developers, students, and the technologists and the tutors. And for a normal user, you're going to learn the concept, and probably the initial part of the videos will be you'll be able to understand. If you go to YouTube and look for Fun Pi videos, these are the latest videos I've added, and you can see the recent videos are all based on Mifare Classic. You can see now I've covered extensively how to work with access rights. You can see part 1, part 2, part 3. And if you scroll down, you'll also see how to work with the value blocks. So what I'll be doing in this video is just to cover up, not in detail, but to make you understand how the PN532 reader writer works with the Mifare Classic tags. Since the screens and the look of the software, it's all the same between the ACR122 reader writer and the PN532 reader writer. If you go and watch any of these videos, you will find the PN532 software identical. These are some of the features of Mifare Classic EV1 tags. These cards are customizable. You can find these cards available in the 7-byte UID as well as the 4-byte UID, and an interesting feature called random ID. So I've already spoken about this maybe a year ago on how to personalize Mifare Classic EV1. And the reason why these cards are popular is there is a feature called the originality signature, which is not available in classic tags. And this feature is also available using on tags like NTAG 213 or the Mifare Ultra EV1. This is a feature where the system integrators can check the authenticity of the card. You can make sure the card is indeed manufactured by the NXP and not a cloned card. As far as my knowledge goes, these cards are not clonable. So if you have come across the Mifare Classic, you know that these are clonable using UID changeable tags, but I've not seen any Mifare Classic EV1 UID changeable tags. So obviously, looks like these tags are very secure. So some of the applications are these cards can be used in access control system, where most earlier access control systems were based on the Mifare Classic tags, and I think now the manufacturers of the access control system probably are migrating towards the tags like Mifare Classic EV1 or much secure cards like the SY. This card suits very well for a multiple application system. So you're going to learn how to create multiple applications in this video series. Now, as I did in all my previous videos, you have to have a copy of the PN532 user manual This document shows the various commands, the syntax and the response structures, and also you can get the document on Mifare Classic EV1 or 4K datasheets. Now I have used Mifare Classic EV1 1K, but you can buy, if you look at the internet, you can buy the 4K size as well, but in my video I'll be using the Mifare Classic 4K. So I'm sure the Mifare Classic tags are not very popular these days, because if you look at the internet, and most blogs says that Mifare Classic tags are outdated and you have to use Mifare Classic EV1 tags. So I'm using this software called PN532 Made Easy version 1.9.3, and you can see I've connected my PN532 board, and this is connected to a USB to TTL cable. And I've made many videos showing you how to build a RFID reader writer like this, and this is the cheapest reader writer you can build. So if you want to learn only about RFID programming, so this will be the most cost-effective way of building your reader writer. So when you click this connect to PN532, at the bottom of the screen you will see the COM port it's connected to, plus the firmware version of PN532. I've not seen any difference in the version number since a few years, and I'm going to choose the Mifare Classic 1K and 4K, and this is the screen I'm going to use to show you or to teach you all about the Mifare Classic. So I'll be using Mifare Classic EV1, which is a 7-byte UID. Now this, as I mentioned before, these 7-byte UID Mifare Classics are becoming very popular these days. First I'm going to show how to use this screen, and after that I'm going to show you make you understand the various command structure, response structure that the PN532 uses. The first thing you do is, after you place the tag on the reader, hit this activate. Now depending on the kind of the card, so I have got here 7-byte because this is a 7-byte UID. So if you hit this read entire tag, the software goes through sends a series of commands to read the entire data. The Mifare Classic 1K has got 16 sectors, and each sector has got 4 blocks of data. So I will advise you to see my previous videos, which I have covered everything in detail. Now on the right side is the grid that shows you the data from the card, so you can directly go to any of the sector and edit and then save. But keep one thing in mind, so before you read or write to Mifare cards, you have to first authenticate. Now just to summarize some of these features, every sector has got a sector trailer, which is highlighted in the gray background. The sector trailer is the most important piece of block. So here is where you find the value of the key A and the value of the key B, and in between you will have the access rights bytes. So you can see I have got, if you look at the grid itself, on the left side is, these are the block addresses. There are 64 blocks altogether, and each block has got 16 bytes. So I have shown this as B0 to B15, followed by, this is the access right of that block, and on the right side you can see what is the sector number and what is the block number. Now this is just a relative blocks. So each sector has got 4 blocks, and the relative block number is 0, 1, 2, and 3. In fact, you don't have to know the relative block numbers, because all the commands will be using only the block addresses. Probably now I might get rid of this block number in the later versions, because this is of no use. So in order to write, and keep in mind you cannot modify the value of the block 0, because this is the manufacturer block, which consists of the UID of the card. You can see here the UID, what you see here, the tag UID is also stored in the block 0, and after that there are few bytes which are the manufacturer data, so which we don't have to know, and because you cannot make any changes to this block 0 data. Now in order to change, now also as you click on the grid, this is the most important section. This tells you now which is the this gives information about the block. So if I click here, so this block belongs to sector 1 and block 2 and the block order 6. In order to make changes to the data block, you go here, you can either start typing the hex number you want. I'm going to type 1011. So likewise but before you make any before you write anything, you have to first authenticate the sector. Now I'm in sector 0. If you choose this sector 0 and the default keys are all FFFs, activate, you should see a message here, activate sector 0, okay. And after that I can write whatever I want. Say write FF and say write. Now you should see the write block successful. On the commands tab you can see all the various PN532 commands that are going on. I'll come back to that soon. Now the write is successful. If you hit this R click, this will read the block again. Say for example, I'm going to just modify this block number 2, but I don't want to save it. If I hit the read button, you can see you got back the old data. Now there are a few shortcuts here. If you go to any sector, say I'm in sector number 1, right click and I can use this autofill feature. Now I want to autofill this entire block or entire sector. I want to autofill this, the value AA, and I want to write this entire sector. Now before I write it, I have to first authenticate, because I have to write the sector 1. First authenticate sector 1. I'm still using the key A. Say authenticate successful. Then I can hit this button, write sector. Now you should see this message here, the right sector, okay. And you can also see there is no single command to write the entire sector. The software is just going in a loop and writing block by block. So likewise, you don't have to always read the entire tag. You can just read the sector you're interested in. I'm going to authenticate again. This time I'm going to go to sector say 15 and authenticate and say read sector. Now you can see here only the sector 15 is read. So I'm going to show you how to change some of this data, some of these blocks to the value block. Value block is what you have to have a value block if you want to use this the parse operations like a decrement and increment. I'm going to show that here. In order to use this increment, decrement operations, you have to first have the data in a correct format, and that format is called as a value block format. If you click here, it will ask you what's the default value you want. I'm going to have the default value as say 100 and the backup address. So this is something you can store. There's no automated backup happening. I mentioned about these value blocks in my previous videos, so please take a look at them. Now I'm going to have a address as say 10. So the number you put here, it's completely dependent on the software application. The card doesn't do anything with this backup address. So don't think that the card is doing the automated backup, which it doesn't. Now as soon as you click OK, this entire block is formatted as a value block. Now I can write. So you don't have to authenticate again because it's already authenticated. So you authenticate once and you can do a number of read and write. Now the block is in a value block format. I can use this increment and decrement operations. The first thing is I can read the value stored in this value block. If you hit this button, read button, so it copies, it basically converts this value block into a number here. In fact, it's very easy to understand the format. The first 4 bytes is where the value is stored. If you convert this hex 64 to decimal, you'll end up getting 100, and all the other bits are the stored just as a redundancy. It has got the complement of this byte, and you also have, in fact, this value 100 is stored twice, from byte 0 to byte 3 and from byte 8 to byte 11, and it also stored in complement here as well. It's a complement of that value, plus it also has got the backup address stored here and here, and the complement of that is stored is here and here. Now there's also one more shortcut here. So using this store button, I can format a block with a value block format. Now assume that I want to create a value block at the block address 61 with the initial value of 1000. If you hit this store button, you can see that it's formatted in the value block format. Now if you try to read, now you have to keep one thing in mind, all these buttons, they depend on the current row that is selected here. Now if I hit this 62, I know this is not in a value block format. If you hit read, you will get, in fact this is an error, but the software shows as a value 0. So once you have this value blocks, you can learn how to do this increment and decrement. Say for example, these are some of the important operations that are used in your travel card or any kind of a royalty cards, where it collects the points. So if I want to increment, so I'm going to increment the value block in block 60. I'm going to increment this by 10. If you say increment, now this value get incremented, and if you read, you'll get 10 more than the old value. Likewise, I can decrement by 50. If you hit the decrement, it's decremented, and try to read it, you get the result. So I'm going to explain about this volatile memory in my next video. Now other thing which you like to do is change the access rights or change the key. So you have to keep one thing in mind, there is no command to change the key values. So changing the key value is a simple write operation to the sector trailer. There's a special name given to this this block that carries the keys. It's called sector trailer. Now in order to do that, I'm going to bring one more sector, say sector 14, authenticate and read this sector. So this time I'm going to write something in this sector. So I'm going to right click, I'm going to use like a text editor. So assume that this is the name of an employee you would like to write. So the employee name goes here, and you can also put okay, that's all you can. So if you say okay, now I've got some data in the first 3 blocks. Now I'm going to write this entire sector. Now the right sector writes only the data blocks, it doesn't write the keys. Now assume that I want to change the value of the key A and key B. You just have to go in. There is a shortcut way of doing that. You can go here. This section is for key A and this for key B. You can go here, or you can directly key in here. Now I'm going to change the value of key A and key B here. I'm going to click. Say I'm going to change this as just want to make a small change. So I'm going to change the first byte as 0, and I'm also going to change the first byte of key B to 0. And if you hit say W, this is a write operation, the key is changed. So I'm going to now reactivate Now if you want to read the value of sector 14, if you try to authenticate, you will get error message because the key is no more 00. It is key is no more FFs. It's a 0. Now you have to keep one thing in mind. Every time there is an error in the card, you have to activate it. So we are going to make this fix, in the later releases where you don't have to activate, because this is a learning software. So this also teaches you that a card like this, if you send any wrong key, this will go into a state where the reactivation is required. I'm going to reactivate. This time I'm going to authenticate with the key. So what I noticed is every time you hit this activate, the sector number goes back to 0. So I'm going to choose 14 and activate. So I'm going to choose the sector 14 and change the key to 00 and hit this activate. The activation is successful. I can read the entire sector. Now in order to change the access rights, you have to first click on the sector tiler block, right click and choose this option, change access rights. Now here, this dialog box you can use to change the access rights of all the 4 blocks. Now I'm going to make just you just have to understand what you're doing here, but the access rights, all the access rights are covered in depth in my other videos. So in this video I'm just going to make this as say set it to 2, and I'm going to also set all these blocks to 2, and I'm going to change this as say something, it could be say 2, but you have to make sure some access rights will not let you change the sector access again. So I'm just looking at that. So that's not a safe one. So I'm going to go with this 4. Here it says I can still go and modify the access rights using A or B. Now once you do that, just go and hit the W here and write is successful. So next time when you try to read, activate, read sector 14, the key is still 00, authenticate, read the sector, you can see that the software shows all the sector data with the corresponding access rights. So what you have learned in this video is how to activate, how to read and write, and how to change the keys. And in the next video I'm going to spend some time on more about how the value block works and what's this volatile memory.